Okay, very good. So you've seen visual, you've seen data wrangling. We're now going to cover data science, and we call it data science reimagined, mass communicating the power of data science to a broad audience. And we've tooled up for this for some time. Spotfire has an embedded R engine that on the client and on the server that allows the data scientist to just inline of the analysis do R scripting and to invoke the notion of a data function, which I'll cover. But the fact that you've got that in, both on the client and the server gives the data scientist that world at their fingertips. It makes it easy for the data scientists to share their work, in fact. So Brad showed you the consumer as well as the client, thick client, and the data scientist in one click can save an analysis to the Spotfire library, and then it's available immediately from the Spotfire web player into a consumer client. So as a data scientist, you can do an analysis, save it to the library, and boom, it's out there for whoever you want to share it with in a web environment. The Spotfire server allows you to do other engines besides R. So we have embedded R because I'll explain to you, we've created our own proprietary runtime for R, so it's embedded in our products, but we can call out to SAS, MATLAB, other engines that you can run on our stat services product on the server to put those analytics into that web client for your end users to see. And the Spotfire library manages all those components for reuse and sharing. So the data functions that I'll get to and the connections to the data source, the templates, the analytic apps can be managed in the library, both for reuse and collaboration, but also for hosting out to your end users. So we've designed our stack to be really productive and quick for the data scientist to do the work and also share it to the audience. And then TIBCO Community, which we'll cover, allows you to share those data science components. We've got a collection of 100 assets of templates, data functions, and so on, and people contribute to that as well as ourselves to allow you to quickly embrace machine learning and that sort of thing into your Spotfire analysis. So that's the setup. And I mentioned we've created our own implementation of R. This was built from the ground up. TIBCO actually owns the S language and the S Plus product through an acquisition. That company acquired the S language from Bell Labs many years ago and had created the S Plus product. And so we put those engineers to work to create an R engine from the ground up. It's been created with various memory management techniques to have much better performance than open source R, but it does run the open source R code and the CRAN contributed packages natively in the engine. So it's designed, this engine, for commercial apps and embedding. It's not a GPL, it's a TIBCO license and supported product. It's not a package, repackage of the open source R engine. Other folks who want to claim credit for integrating with R require their users to go download open source R, create an arm's length connection to it, and then do this get post thing. We actually, because we own this engine and we own the license on it, we can embed it, and that gives that level of extra performance.
Hey, Michael, just want to throw out one quick comment too, and as a matter of fact, we sell it on an OEM basis too. So two of those data wrangling players, NIME and LavaStorm, both OEM the TERR engine inside their application for statistics for execution of our scripts.
That's dead right. I've got a list of those here in a minute.
Okay.
This TIBCO Runtime R engine extends the reach of R out into the enterprise. You can develop your code in open source R, but you can deploy on a commercially supported and robust platform. And this allows you to build these analytic apps and deploy them out to your community. And as Brad just added there, this TERR engine, it's embedded in our own stat services server product, our grid server, our cloud compute grid, stream-based business events, our event processing products. But Brad mentioned NIME and LavaStorm, who've OEM'd this engine and put it inside of their products as well. You can also put it out onto a cluster and have it do parallel analyses, say on a Hadoop cluster and that sort of thing. So it's embeddable. We have the license, and we do use it internally and use it with various partners. So what does this TERR engine do inside of Spotfire, which is what we're showing you today? Well, it adds stats to the visual environment. I'll show you in the demo certain analyses. You do the right click and you have context to do a forecast. So that forecast, for example, is coming from the inbuilt TIBCO R engine. The data wrangling that Brad showed, there's a whole other, besides the point and click, there's a whole other environment that has like 400 inbuilt functions where you define functions with our inbuilt calculation engine but you can also use the TERR engine for that as well. So you can write R code into these expressions to wrangle your data, and you can save those as reusable functions. That's very helpful doing calculations like, you know, NPV or various statistics that you want to add onto your graphs. Now it also runs these data functions. I'm going to show you what that is in a minute, but anything you can do in R that has parameters, you can parameterize those in Spotfire with inputs, and you can bring inputs of your columns of data can go input to those functions, and the outputs come back as part of your Spotfire analysis. So the TERR engine is sitting there inside Spotfire, and you can run your R functions with inputs and outputs and have that just be part of your interactive, immersive Spotfire analysis. Now it also powers, we have a set of predictive modeling tools. Brad, in his demo, showed that automatic clustering. That's one of our predictive modeling tools in our menu system. And a number of those predictive modeling tools use this TERR engine for doing their regression, classification, that sort of thing. And then finally, we can extend the Spotfire graphics palette. So in the R language, you can create polygons, and we can save those and bring them onto our map chart, and those polygons then become interactive just like the rest of the Spotfire analysis. So there's a little screenshot there of a polar plot where you can highlight different cells and drill down, drill across to other Spotfire analyses, but that was written with a piece of R code. So that's sort of what it does there. Now let me jump out and I'll show you what a data function is. I think it's better to see that hands-on. This data set is a set of locations of geology exploration sites in Western Canada. And the common problem is you've got some locations where you don't have all the data, that you need that to kind of do the prediction of the production of oil from that site. And we're going to use this contour lines analysis to do a smooth curve across that to interpolate the values of those. And we're going to do that through a function contour lines in R. So let me jump out to this demo.
Nice. Okay,
so here's the Spotfire dashboard. And here's those layers I mentioned. You know, if I turn off if I just keep the non-missing values on there. So these are the data point, the areas where we do have the geology data, and you see a number of areas where we don't have the geology data. We want to do an interpolation to find those, to match up with production, to see what is predicting production and so on. Okay, so I'm now going to insert a data function to do that. Let me insert a data function. I'm going to go to my library and pick off this contour lines data function. I'm going to add that onto into the analysis, and I'm now going to map it. So the inputs that I've defined in the data function, you know, this x is the longitude. So let me go into my Spotfire analysis, the data table, and find the column longitude. It's automatically matched there. Y is the latitude. Let me go pick off the latitude for y. Z is the variable that I want to do the contour analysis on. So let me pick off one of these geology variables for the Z variable. I'm also going to add a smoothing parameter in here that I've got represented in the analysis here as a document property. And now I'm going to bring the output back. I'm going to bring the output back as a data table. This data table, I'm going to call it contour lines, and that's it. I can now basically click OK on this. The TERR engine is going to take that command to build that contour lines table. And it's going to drop that back in as a data table here. Now I can grab this data table and drag it on, and you can see there's a little binary mapping object that I can drag it onto. And I do that, and it lands directly on my Spotfire map. So we can control the format. It's coming back as a binary object. Now I can right-click on this and set the properties, and I can jump down into the mapping is pretty cool. It's you can arrange the layers and so on. I'm going to put the contour layer here. I'm going to go into the settings of it, and I'm going to, let's see, firstly make the lines a little bit thicker. Now I'm going to change the colors here based on the level, and I'm going to make the high color match the red here, which is the same as the points. I'm going to make the low color match the blue here. So keep that in line with the coloring of the points. Then I'm going to go back over here and let me close that out. And now I'm going to move this up to the top of the stack so that I can see it better. And so voila, with a few mouse clicks, I've done this data function contour analysis, laid it on top of the map, and now I've got a way of interpolating these data to come up with the best value for that geology variable that in open circles that's missing, that's now going to allow me to predict production as a function of geology. Now this is all very accurate on the map. It's the piece of R code that's done inside there. I can take a quick look at that. Here's my data function here. Here's the R code that's involved in that. It's pretty simple. Basically a call to contour lines. There's a little bit of setup and explanation, a little bit of headers and so on. But that gives you an idea of how a data function works. And if we jump back to the presentation, I've been able to put that onto this map very quickly from a data function.